finally figured it out. We all know that men are from Mars and women are from Venus. But I thought that was just an analogy for the way men and women communicate. But no, it's really about the planets, or more specifically, the strength of gravity you would feel if you lived on Venus or Mars. You see, the planets have different levels of gravity. And it turns out that the way gravity changes affects the way our brain functions. Now, I've just been jesting about this whole male-female relationship analogy, but we're really finding out that gravity affects the brains of men and women differently. Now, how do I know this? I'm a neuroscientist, and I study the brains of astronauts before and after spaceflight. And NASA sends astronauts up to the space station for months at a time. On the space station, the astronauts are circling the Earth at 17,000 miles per hour. That is so fast that the astronauts experience a sunrise and sunset every 90 minutes. Now, the fact that it's moving so fast, it creates centrifugal force, sort of like you would experience on a tilt-wheel ride at the carnival. And that centrifugal force counteracts the force of gravity that they still experience on the space station. So ultimately, they get this feeling of weightlessness. Now you might think, well, that'd be fun, just kind of floating around, not having to worry about the bathroom scales. But you know, actually, the lack of gravity is really harmful for your body. Astronauts experience cardiovascular deconditioning, they lose bone and muscle mass, they have changes in their immune response, they have changes throughout their body. And let me add one more area. The brain. The lack of gravity actually affects their brain as well. So my team and I, we've been looking at pictures of the brains of astronauts taken before they went into space and then when they came back. And if you compare the two, you see widespread changes in the brain structure of the astronauts. In fact, there's a special area in the center of the brain that's filled with fluid, and it enlarges after spaceflight. It's called the cerebral ventricles. Now, we don't know the full consequences of these structural changes that occur to the brains in the astronauts, but we're learning in more recent research that perhaps these structural changes are linked to changes in mental performance of the astronauts. And that's important because when they land on a different planet, such as Mars, they're going to have physical fitness, mental sharpness. They're going to have to be able to anticipate anything that they might experience. And they can't take anything for granted, not even gravity. You know, doing something here on Earth seems really, really simple, such as getting out of your car. And you'd think that getting out of a spaceship would be just as easy. But it's not. It's really complicated to do things in space. And so it's going to require mental sharpness of these astronauts. But you know, to get all the way to Mars, they're going to have to travel for months. And during that time, the lack of gravity is really going to have its toll on their body. Just getting out of that spacecraft and walking around again for the first time after months is going to be challenging. Think of the worst case of sea legs you've ever experienced and double that. So the astronauts are really going to have to be in shape. Here on Earth, currently, what NASA does is the astronauts land in a remote location and they have special ground crews that come and help them. They even have to carry the astronauts out of their space capsule when they get back here on Earth. But that's not going to be possible on Mars. There's not going to be anyone there to help them. In order to survive, they're going to have to take care of themselves. And they're going to have to be in peak mental fitness to be able to do that. And so that's why we're studying what happens to the brain during this lack of gravity. And we're finding some pretty interesting stuff. We're finding that a long-term lack of gravity leads to loss of balance control. And interestingly, it's more severe in the female astronauts. But then, on the other hand, in case you think we should just be sending men, female brains have been found to be more resistant to galactic cosmic radiation. Now, that's a big mouthful to say the type of radiation that astronauts will experience on the way to Mars. In a study looking at male mice exposed to this type of radiation, they found that afterwards the mice had problems with mental function. But guess what? The females acted like they had hardly been affected at all. So these gender differences are important to understand. And in particular, let me ask you a question. How many people do you think that have gone into space, what percentage do you think have been female? Anyone know?
Maybe 3.
I hear a wide range out there. It's actually 15%. So just like women here in science and engineering and math, women are also underrepresented in space. That was highlighted recently in March of 2019 when the first all-female spacewalk had to be canceled because there weren't enough appropriately sized spacesuits on the space station for the 2 women at the time. But luckily, that's all changing. NASA is now recruiting more balanced numbers of males and females to include in their astronaut classes. And soon, within the next 5 years, NASA's planning on going back to the moon. It's called the Artemis program. And this time, it won't just be men on the moon, it will be women there with them as well. So that's why our work is really important, understanding the ways that gravity affects the brain. But to study that, it's very limited opportunity to have access to astronauts because so few people go into space now. But we found one really cool, unique way to study weightlessness here on Earth without even having to go into space. It's called parabolic flight. Now, what happens during parabolic flight is a plane, big plane, a Boeing 727, goes up and down really fast 30 times in a row. And as the plane moves up and arcs over and drops down, the passengers inside experience brief periods of weightlessness. And during these periods of weightlessness, we can study what's happening to the human body. And as a matter of fact, recently, my team and I just studied what happens to the brain and ongoing brain activity, how it's affected by weightlessness during parabolic flight. And it was wonderful. So this work that we're doing here is important because not only are we understanding what's happening to the brain to support our future space explorers, but it's also applicable to what's happening to our patients here on Earth. In the whole history of NASA and the space program, technologies that have been developed for space have been applied here on Earth. Take, for example, GPS. Our cell phones, can you imagine GPS that's powering those Google Maps, how reliant we are on that for our everyday life? Well, in the same way, studying the human body in space also gives us information to understand, to apply to our patients, like the gender differences that we're seeing in the brain's response to gravity. And in fact, several neurological disorders affecting the brain disproportionately affect females. For example, multiple sclerosis, anxiety, depression, and Alzheimer's. Out of the 5.8 million Americans with Alzheimer's, 2/3 of those are women. So we really need to understand these gender differences in how the brain functions, and our work that we're doing with NASA is helping us understand that. For example, we're learning how important, in addition to just taking care of our lives, ourselves in our daily lives generally, how important it is to get up, move about, and experience gravity every day. So when you hear men are from Mars and women are from Venus, just chalk it up to differences in the effect of gravity on their brain. And remember, regardless of the wrinkles and saggy body parts, gravity is our friend. Just think about what it's doing for our brain health.